I'm Anil Kumar. Welcome to my series on discrete functions. In this video, I'm going to discuss with you a complete test paper on sequences and series. Our focus will be on arithmetic and geometric sequences and series, and we'll also take up recursive formula and general formula for different types of sequences. Here are 13 questions to share. These are from previous test papers, and I hope their solution will help many others. So have a good look at these questions. You can always pause the video, answer these, and then look into my suggestions. Now for some questions, especially question number 1, which is write the recursive formula for the general term Tn equals to 2n square minus 2n, I'll provide you with different types of solutions that will help you to adopt an approach which is good for you, right? So the other questions on this page, especially the 13th question, is right here before you. You can now copy these questions, solve, and then look into my solutions. So let's begin with the solution of the very first question, which is probably one of the toughest in this particular test paper. Write the recursive formula for the general term Tn equals to 2n squared minus 2n. So we are given a general term which is Tn equals to 2n squared minus 2n. When I say recursive formula, we have to write Tn in terms of Tn minus 1, correct? So one of the approach for this could be that you could just write all the terms, right? So starting with 1. So if I substitute 1 here, what we get here is 2 times 1 square minus 2 times 1, which is 0. And then second term will be 2 times 2 square minus 2 times 2. So that is 4 times 2, 8. 8 minus 4 is 4. Then we get T3 equals to 2 times 3 square minus 2 times 3. So 9 times 2 is 18, and from 18 we have to take away 6, so that leaves us with 12. Well, you can always use calculator in this test paper, right? So remember, the calculator is allowed, so you can definitely use calculator, correct? So but wherever possible you may avoid it, right? So it is n is 4 for us now, so we have 4 here. 16 times 2 is 32, and we'll take away 8, so which leaves us with 24, right? Let me go one more term here. So we get 2 times 5 square, which is 25 times 2 is 50, and we have to take away 10, right? So it becomes 40 for us. So that is how we could actually continue, and we get an idea of the different elements in this particular sequence. So what you notice here is that we have 0, 4, 12, 24, 40, and so on. Now, how do I get recursive formula from these terms? That is a real big question, correct? So you could do trial and error, or what I would like to do here is go with first and second difference, right? So we could actually do first difference and second difference. So whenever you have a sequence, it could be linear if the first difference is constant, correct? If the first difference is not constant, then it is quadratic. It could be a polynomial, but we know that here we have the first difference because that is the general term. So the second difference is constant, right? So it is a quadratic for sure, as you can see here. Now, what we could do here is rewrite these values as combination of previous term and the new term. What I'm trying to say here is we know T1 is 0, right? T1 is 0. Now T2 is 0 plus what? T2 is 0 plus 4, correct? That is how you get 4, and then you get 4 here. Now to get T3, I have to begin with 4, and what should I add to 4 to get 12? It is 8, right? So that gives us 12. And then here, we'll begin with 12, and what should I add to 12 to get 24? It is 12 indeed, so we get 24. Now, to 24, what should I add to get 40, right? So it is 16, and that is how the process is going on. Do you see this part? So what you see here is that where this term is t n minus 1, right? So n minus 1 plus what is what our recursive formula is, right? So we figured out that previous term times we have to add, for the second term we have to add 4, for the third term we have to add 8. Now how do we get this? So one of the ways which we can think about is, these are all multiples of 4, right? These are all multiples of 4. Okay. Now 4 times what is 4? 1. 4 times what is 8? 2. Now 2 is 1 less than 3. So therefore we could write this as n minus 1. Do you get an idea? So now here we can now write down the recursive formula. Okay. So we can say that recursive formula could be like this. So whenever you write recursive formula, you have to write the first term, and we say the first term t1 is equal to 0 and tn equals to tn minus 1 plus 4 times n minus 1. Is that clear to you? So that is how we will get the solution of this particular question. Now this is one approach. The other approach could be that we could do, let me write down here, method 1. Now let's do method 2. Now we could figure it out, correct? So it is always possible to figure this out, no problems. But here is a general method. Since you want tn minus 1, we know that tn is given to us as 2n squared minus 2n. So what is tn minus 1? Let's figure this out. We have to replace n with n minus 1, right? So we get 2 times n minus 1 whole square minus 2 times n minus 1, right? We could have simplified also and then done it. Okay. So now, okay, so basically we have 2 times n minus 1, and if I take within the bracket, I get n minus 1, and this is minus 1, correct? Because we have taken 2 times n minus 1 in the bracket. So we get 2 times n minus 1 times n minus 2. Anyway, we have to expand. So let us expand. We get 2 times n is n squared, and minus 2 n, and this is minus n, and this is plus 2. So we do get something like 2n squared minus 4n minus 2n plus 4, something like this. So when you expand, you may or may not do these steps. Finally, you get this. Now, see, tn is 2n squared minus 2n. So from here, this 2n squared minus 2n is a part of tn, correct? So we could combine these, right, and rewrite our expression as 2n squared minus 2n. And here we are left with minus 4n plus 4, correct? So these two terms are tn. Do you see that? So we could now write this as tn, and here, well, we can take 4 common, right? So if I take plus here, so we can take minus here common, 4, right? So we get what? We get n minus 1 here, correct? So Tn minus 1 is Tn minus 4 times n minus 1. So let's rearrange this formula. So when you rearrange, you get Tn equals to Tn minus 1 plus 4 times n minus 1. Is that clear to you? And of course, we have to write down what is the first term, right? So when I substitute T1 will be equal to 0. Since I substitute 1 here, I get 0. So you could actually get your formula by substituting n minus 1 and then rearranging your terms. Right? So this is a general method which can be adopted whenever you are given a general term and you want to find a recursive formula. So I hope that makes sense. So finally, we do get our answer, and we can write down the answer, which is Tn equals to Tn minus 1 plus 4 times n minus 1, where T1 is equal to 0, correct? So that is how you can adopt any one of these methods and get your result. So I hope the concept is absolutely clear. Now let's move on and take the next question. Question number 2. Write the general term for recursive formula T1 equals to minus 4 and Tn is 2 times the previous term. So 2 times the previous term indicate that it is a geometric series, right? So we are given T1 equals to minus 4, that is the first term, and the next term Tn is represented as 2 times the previous term, Tn minus 1, right? So if you could identify that this is a geometric series, right? So we can know this is geometric sequence. In that case, you know what could be the general term, right? So general term will be, you can always write that as Tn equals to a times r to the power of n minus 1, where a, the first term here, is minus 4, right? And r is 2. Right. So that is how you could get a general term in this particular case, okay, from a recursive formula. Now, if that is not, very obvious, in that case, what you could also do is you could write your series, right? You know, T1 is given to us as minus 4, and Tn is equals to 2 times Tn minus 1. So just multiply this by 2 to get the second term. So second term will be 2 times minus 4, which is minus 8. Third term will be 2 times minus 8 to get minus 16. And fourth term will be 2 times minus 16, which is minus 32. And now from here, you can see that the first term, a, is minus 4. Second is this. So this is a geometric sequence. Now, since it is a geometric sequence with the first term as minus 4 and r, the ratio 8 over 4, both negatives cancel, equals to 2. You can write the general term Tn equals to, minus 4, right? So first term is minus 4. So minus 4 times 2 to the power of n minus 1. Doesn't make sense. So that becomes our solution for question number 2. Perfect. Now let's take question number 3, which is, we are given that T3 is 19 and T15 is minus 17 in an arithmetic sequence. Find T47, right? So we have an example of arithmetic sequence. Now in arithmetic sequence, you know what is nth term, right? You can write Tn equals to a plus n minus 1 times d. That is arithmetic sequence. Now, when you are given that T3 equals to 19, we could write this T3 as a plus 3 minus 1 times d, or we can say 19 equals to a plus, this is 3, right? So this 3 minus 1 is just 2d, correct? Now for T15, which is given to us as minus 17, we could write this as a, which is, we need to find a and d, plus 15 minus 1 is 14, so we can write 14d. So we basically get two equations from here, equation 1 and equation 2. And from these two equations, we can always find A and D. So if I do equation 1 minus equation 2, then what do I get? So this minus this, that gets added up. 9 plus 7 is 16, and then 36 equals to A and A cancel. And 2 minus this gives us minus 12D, right? So that means D is equals to 36 over minus 12, which is basically equal to minus 3. So we get the value of D as minus 3, correct? Since D is minus 3, we can now find A by substituting in any one of our equations, correct? So we could use equation 1. So we have 19 equals to A plus 2 times D, right? And we know D is equals to minus 3. Substituting, we get 19 equals to A plus 2 times minus 3, or 19 plus 6 is A, which is 25. So we get A is 25. Now we need to find what T47 is. So T47 will be equal to A plus n minus 1 times D. Since n is 47 and we know A is 25, so we can write this as 25 plus 47 minus 1, and D is minus 3 for us, correct? So we get this as 25 plus 46 times minus 3, which is 25. You can use calculator, right? 6 times 3 is 18, and 1, 3 times 4 is 12, and 1, 38, and that gives you a negative number when you take away 3, and then this is 1. So we get 113 as T47. Clear? So that is how we could actually answer this particular question. And now let's move on and take the next question, which is question number 4. We need to now write a general term for minus 3, 15, minus 17, 3, 75, and so on. So what you notice here is, let's work out the ratios, right? Let's work out these ratios. So we have 15 over minus 3, which is equals to minus 5, right? The second ratio is minus 75 over 15, which is also equal to minus 5. And the third ratio, 375 over minus 75, is also minus, right? And 5 times this, just try it out. 5 times 7 is 35. It works, right? So we basically have a geometric sequence where A is minus 3 and R is equal to minus 5. Correct? So since it is a geometric sequence, we can write that the general term is A times R to the power of n minus 1. We need to find the 8th term, right? So T8 will be equal to minus 3 times minus 5 to the power of 8 minus 1, correct? And this can be calculated using the calculator. So we have minus 3 times minus 5 to the power of 7, correct? So let's use calculator to figure this out. We know this is going to be negative, and negative times negative is going to be positive. So let's write positive here. So we'll do 5 to the power of 7 and then multiply this by 3. So we get a very big number, which is 234375. So that's the number which we get. So let's write this down. So we get 234375. Is that clear to you? Correct? So that is how we are going to get this solution. So I hope all the steps are absolutely clear, right? Let's move on and take the next question now. Question number 5. For the arithmetic series minus 40, minus 25, minus 10, plus 5, plus so on, find the sum of 52 terms. So we are now talking about arithmetic series, and we know A is equal to minus 40, correct? D, the common difference, is difference between the two. So you could see difference between any two of them. So if you do that, what do you get? So here we can take up any terms. So we have minus 10 minus 25, for example, between these two terms. So it is equal to minus 10 plus 25, which is 10 minus from 25 is 15. And we can also check that this difference is indeed constant. 5 minus 10 is 5 plus 10, which is also 15, correct? So the common difference, D, is 15, right? Now we need to find the sum of 52 terms. Now whenever you have an arithmetic sequence, then sum of n terms is equal to n over 2 times 2a plus n minus 1 times d, right? So that is the formula. Now here we know all the terms. We need to find S52. So S52 will be equals to 52 divided by 2 twice a is minus 40 plus 52 minus 1, and d is 15 for us. So we have half of this, which is 26 times minus 80, and this is plus 51 times 15. So let's use calculator to figure this out. So we have 51 times 15, and from this we'll take away 80, and then we'll multiply this by 26 to get our answer, which is 17810. Correct? So that is how we are going to find the solution of this question. So this is a straightforward knowledge-based question on arithmetic series sum. Okay, question number 6 here is, for the geometric series, now we are given a geometric series, we have to find sum of 7 terms, right? So since we are given geometric series, we can actually find the ratios direct away, right? So we know A in this case is 100. R is the ratio of the two terms, so it is minus 50 over 100, which is minus half. You can check with 25 and minus 50 also. So every term is negative half times the previous term, right? Now sum of series formula for the geometric series is A times. Now whenever R is a smaller number, you normally write this as 1 minus R to the power of n, right? So that is what we do. Normally we write 1 minus R to the power of n over 1 minus R, correct? So that is what the formula is. We need to find sum of 7 terms. A is 100 for us. 1 minus R. R is minus half to the power of n, which is 7. We have 1 minus R, which is minus half. Correct? So that is how we can write it down. So we can now use calculator to figure this out. Anyway, let me simplify this. So minus 7th power will be positive. So let me write 1 plus, and we'll have half to the power of 7, since the negative will remain negative when we have odd power, correct? So that is all. And 1 plus half is 3 by 2, right? Or 1.5, we can write 3 by 2. Okay, now use calculator to find this answer, which is, we have half to the power of 7, say 0.5 to the power of 7, and then we'll add to this 1, and then we'll multiply by 100, and then divide by 1.5. In decimals, this is equal to 67.1875. Okay. So that becomes the sum of 7 terms, correct? Let's move on and take the next question now. Question number 7. Find the sum of the series 4 plus 11 plus 18 plus so on till 88. Now here we have to do two things. First, figure out what type of series is this, and second, number of terms. So if you see this difference, 11 minus 4 is 7, and this is also 7. So this is a arithmetic series. Okay, and the nth term is 88, so we can find n from here, correct? So we at least know two things about it, that A is equal to 4 and the common difference D is equal to 7. Now we have to find the number of terms in this particular series. We know the formula that Tn is A plus n minus 1 times D. So Tn is 88, so 88 is equal to 4 plus n minus 1 times 7. So we can write this as 88 minus 4 divided by 7 is equal to n minus 1. So let's do this. So we have 88 minus 4 is 84, and when we divide this by 7, we get 12. So we have here 12 equals to n minus 1, or 13 is the value of n. Correct? So we know all our parameters now. That is to say that A is equal to 4, D is equal to 7, n is equals to 13, and we need to now find the sum of the series. So we are looking for sum of the series, and the formula for sum of the series is, it's an arithmetic series, so n over 2, 2a plus n minus 1 times d. You could also use t1, and we'll use alternate formula also to find this, correct? So now, for now, I've written this. So we have n is 13, 13 over 2 times 2 times 4 plus n is 13, 13 minus 1 times d, which is 7 for us. So let's figure this out. So we have 12 times 7, we are starting from here, plus 8, and then we'll times it with 13, and then divide by 2. So we get this answer as 598, right? So that becomes the sum. Now, for the sum of the series, the alternate formula is pretty good in this particular case. So let's see the alternate solution also. So the alternate formula for the sum of the series will be Sn equals to t first term, which is t1, and plus the last term tn times half of number of terms, right? So that becomes a general formula. We can always use this to find the sum for our 13 terms. So we have sum of 13 terms, in this case, equal to first term is 4 plus 88, right, times n is 13 over 2, correct? And let's figure this out. So we have 88 plus 4 equals to times 13 equals to divide by 2 is equal to 598, right? So the other formula is pretty good when you're given the first and the last term. So I hope that makes sense. Let's move on and take the next question now. Question number 8. Find the sum of the series 2 plus 6 plus 18 plus so on till 1458. So first thing is identify the series. So we can see that the first term A is 2. And now how do we get the next term? Times 3, right? So it is a geometric series, right? Where we have first term as 2 and it is a multiple of 3 each time. So that is 6 divided by 2, 18 divided by 6 is R, which is equal to 3, right? So how did we find this? 6 divided by 2 and then 18 divided by 6. So all are equal to 3, right? So we are assuming this to be a geometric series. Now we need to now find what is this term number. So in a geometric series, to find the term number, we have the formula, which is general term Tn is equals to A times R to the power of n minus 1. Now nth term is given to us as 1458. A is 2 for us and R is 3. So we can divide 1458 by 2. We get 3 to the power of n minus 1, and that is 7, and 7 2 and 9, 729. 3 to the power of. So we have to look for what power of 3 could be 729, correct? We know 3 to the power of 4 is 81, and if I multiply 81 by 9, so it means 4 plus 2, right? So that will give us the power of, so we could write 729 as, we can check this out, right? So 729 is equal to what? Seven 29 is 3 to the power of 6, right? So it is 3 to the power of 6 is equals to 3 to the power of n minus 1, correct? So from here we can find the value of n. So we have n minus 1 equals to 6, or n equals to 6 plus 1, so we get n equals to 7, right? So now we know what n is. So once we know what n is, we can find the sum of the series using the formula, correct? So now let's find the sum of the series. The formula for sum of the series is S of n equals to a times r to the power of n minus 1 over r minus 1, right? So we want sum of 7 S7. So a is given to us as 2, r is 3, right? So 3 to the power of 7 minus 1 over 3 minus 1, correct? So that gives you 3 minus 1 cancels, so you get 3 to the power of 7 minus 1, and 3 to the power of 7 will be, basically, let's multiply 720, let's calculate. So we have 3 to the power of 7, and then we'll take away 1 from here. So we get 2186. So our answer here is 2186. Is that clear, right? So that is how you could actually solve such a question. In an arithmetic series, T10 equals to 33, S16 equals to 432, find the first three terms. So in previous examples, we were given the series and we were finding the sum. Now we'll kind of do the reverse. We are given a term number, which in this case is T10, and that is equal to 33. We are also given sum of 16 terms, and that is 432. Now this is arithmetic series we're talking about, correct? So in arithmetic series, the formula for the terms is Tn equals to a plus n minus 1 times t. So we can substitute these values. N is 10 for us, and Tn is 33. So we can write this as 33 equals to a plus 10 minus 1 times t. So that gives us an equation which is 33, equals to a plus 9d, right? So we'll call this as our equation 1. Let me rewrite this as 33 equals to a plus 9d. Second, we'll get from the sum. For the sum of 16 terms, in terms of a and n, the formula is S of n is basically equal to n by 2 times 2a plus n minus 1 times t. Now here, S16 means there are 16 terms and it is 432. So 432 equals to 16 divided by 2. Replace n with 16, right? So 2a plus 16 minus 1 times t. So that is, we can simplify this. So we can just say 432 divided by 16 divided by 2 is 8. So we can divide this by 8 is 2a plus 15d, right? Dividing by 8, we get 8 times 5 is 40, 32 is 4. So 54 is 2a plus 15d, right? So this is our equation number 2. So let's rewrite this equation here. So we have two equations and two unknowns we can easily solve. So we have 54 equals to 2a plus 15d. We can multiply the first equation by 2. So we get 66 equals to 2a plus 18d, right? Getting the equation 3. And now if we subtract one from the other, so if I do equation 3 minus equation 2, this minus that, so we get here 12 equals to 2a cancel, and 18 minus 15 is 3d, or we get 12 divided by 3 as d. So d is 4 for us. So we have the value of d, which is 4. Now, since we know what d is, we can now find the value of a using one of our equation. Let's substitute this in equation 1, which is 33 equals to a plus 9 times d is 4. So we get here 33 minus 9 times 4 is 36 equals to a, or minus 3 is the value of a. So we get here a as equal to minus 3 and d as equal to 4. Now we can always find the first 3 terms of the arithmetic series, right? So it is the first term minus 3, keep on adding 4. So when you add 4, you get plus 1, then 4 means 5. So these are your first 3 terms. Correct? So that becomes your answer. Is that clear to you? So that is how you can actually solve this question. Now let's move on and take up question number 10. Question number 10 is, this Indian snack bar finds its profits from the sales of samosas increase by $25 each day during the 10-day of Toronto International Film Festival. Find the profit for this duration if the profit for the first day is $80. So we are given first day profit. So let's call this as A, which is $80. It is increasing by 25 each day. That means D is 25. We are already given that this is constantly increasing by 25. So basically we are working on arithmetic series, right? And now we know that total number of terms are 10 since it is for 10 days, right? So we know n is equal to 10. We need to find the profit for this duration if the profit for the first day is 10. So profit for n days will be S of 10, correct? So we want to find the profit, which is sum of all these profits starting with $80 on the first day, right? So sum of profit formula can be utilized. So sum of arithmetic series is n by 2 times 2a plus n minus 1 times d, right? We can substitute the known values to find this sum of first 10 terms starting with 80, right? So n is 10, so we get 10 over 2. 2 times a is 80 plus n is 10, 10 minus 1, and d is 25. So we get here 5, 160 plus, well, 250 minus 25 is 175. So that becomes our answer, right? So we get 5, 7, 6, 13, 3, 1, 3, 3, 5. And multiplying by 5, 5 times 5, 25, 2, 15 and 2, 17, 1, 16, 75. And the profit is in dollars. So our answer here is $1675. Correct? Question number 11. Expand 4x minus y to the power of 5. Now you could use binomial theorem here. So there are two options. You can use binomial theorem or you can use Pascal's triangle. Now I find it simpler to use Pascal's triangle, so we'll go with that. So beginning with 1, we'll just make our structure 1, 1, and then it just continues. So we have 1, 2, 1. So 1, add the previous 2, right, to get the next number, correct? in this series. So 1, 4, 6, 4, 1. So this is the fourth row, and now we are looking into the fifth one. So 1, 5, 10, 10, 5, and 1. So these are the coefficients, right? So using these coefficients, we can always expand, right? So let's figure this out. We have 4x minus y to the power of 5. So what we get here is the first term, coefficient is 1, but the power is 5. So we get here 4x to the power of 5 plus, now we get coefficient of 5 times 4x to the power of 4 and minus y to the power of 1, right? Next coefficient is 10, 4x to the power of 3 minus y squared, and then we have again 10, so let's write down here, plus 10 is the next coefficient, and we have 4x squared times minus y cubed. Their sum will always be 5, okay? Then we have 5, we have 4x and minus y to the power of 4 plus 1 is the coefficient now, and we get minus 5 to the power of 5, correct? So we can actually expand and simplify this. So let's calculate. So we have 4 to the power of 5, which is 1024, x to the power of 5, plus we have 5 times 4 to the power of 4, so 4 to the power of 4 times 5, 1280, right? So we get 1280 x to the power of 4 and minus y. So we'll write minus y next time. Now here we have plus 10, so 4 cubed, 64, 640 x, and this becomes y square, which will be positive. Then we have plus 10 times 4 square is 16, so we'll do 160 x square minus y cube, okay, and then we have plus 4 times 5, 20 x y to the power of 4, and then we have minus y to the power of 5. So let's correct this sign here. So we get 1024 x to the power of 5 minus 1280 x to the power of 4 y, and then we have plus 640 x y this should have been cube, right? So let me check if I did this right. We have 460, yeah, 4x cube, right? And then we have a square, so we'll write plus, or rather minus, because this minus will be minus 160 x square y cube, that will be plus 20 x y to the power of 4 minus y to the power of 5. Okay? So when you expand, this is what you will get. Alternate numbers should be negative since you have minus y there. Perfect. And the sum of all these exponents will be 5. So here I think I missed 640 y square. Okay. Sum will be 5, right? So it's good to check and rewrite. Okay. Question number 12. Question number 12 here is, the first term in a sequence of number is t1 equals to 5. The terms that follow are defined by the formula tn equals to, is given tn minus, so we'll take tn minus 1 to the right side. So I'm writing this as tn minus 1 on the right side, and then to that we are adding 2n plus 3. So I'm taking this to the right side and then writing the nth term in terms of tn minus 1 plus 2n plus 3. We need to determine the value for t50 from this particular sequence, right? So we are given a recursive formula, right? So we are working with recursive formula. So one method could be that let us find the other terms. So what is t2 equals to? So t1, which is 5, plus 2 times 2 plus 3, which is 2 times 2 is 4. 4 plus 3 is 7, right? So we get 5 plus 7, right? Which is 12. Now t3 will be 12 plus 2 times n, which is 3 for us now, plus 3, which is 12 plus 2 times 3 is 6 plus 3 is 9, right? So you see this is also stepping up by 1, and we get here 21. T4 will be 21, the last term, plus 2 times 4 plus 3, which is 21 plus 8 plus 3 is 11, and you get 32. And we can write the last term as 25. 32 plus 2 times 5 plus 3, which is 32 plus 10 and 3 is 13, which is 45, correct? So likewise, this is the series which you get. Now we need to determine T50. How do we figure this out, T50? Well, we can look into the trend and then find the value. So since it is a quadratic expression, right? Since it is a quadratic expression, let's find a general term. So basically, let's find a general term. So we can say general term Tn will be, since it is a quadratic expression, we write n squared plus b times n plus c, correct? Now we can substitute n as 1. So this is for n equals to 1, and this is for n equals to 2, correct? So if I substitute n equals to 1, I get t1, which is 5, equals to 1 plus b plus c. That is one of our equations. And if I substitute n equals to 2, t2 is 12, so we get here 12 equals to 2 squared is 4 plus 2b plus c, right? So that becomes our equation 2. Now if I take away one equation from the other, in that case, what do I get? So we get minus 7 equals to, this is minus 3, and here we have minus b, and c vanishes. So we get b equals to 7 minus 3, which is equal to 4, right? So that is our equation 3. Now since we know what b is, we can use the equation 1 and then find what c could be, right? So we can use these two and we can find what c could be. So from here we know 5 equals to 1 plus 4 plus c. So that implies 5 equals to 5 plus c, and that gives you c equals to 0. So that becomes our equation 4. So we know now both b and c, and therefore we can say that the nth term is basically equals to n squared. Value of b is 4 plus 4n, right? And c is 0. So that becomes our general term. Is that clear to you? Now from this general term, we can find what T50 is, right? So now let's calculate what T50 is. So T50 will be 50 squared plus 4 times 50, correct? Which is 2500 plus 200. So that is 2700. So that becomes our answer, correct? So we have T50 equals to 2700. Now this is a very interesting and useful example. I'd like you to once again go through this and then look into the solution of the last question here, which is question number 13. The first three terms of arithmetic sequence are, we're given numbers as 2x minus 5, 5x plus 3, and x squared plus 2. Find the values of x and calculate the values of the first three terms. We have to find what x is, correct? And we are given arithmetic sequence. Okay. Now that means we have a common difference, right? So we have common difference d. So d basically will be 5x plus 3, take away 2x minus 5, correct? So we get 5x minus 2x as 3x, and 3 plus 5 will be 8. So we know d is 3x plus 8. So that really means that if I add, so we have this to this is plus d, right? So here also when I move, I have to plus d2 to get x squared plus 2. Now that really means that x squared plus 2 should be equal to 5x plus 3 plus d, right, which is 3x plus 8. So we have x squared plus 2 equals to 8x plus 5 and 8 is 11. And we have a quadratic equation, x squared minus 8x plus 2 minus 11 equals to 0, or x squared minus 8x plus 9, minus 9 equals to 0, right? So if I solve this equation, we know the value of x. So the equation to solve is x squared minus 8x minus 9 equals to 0. 9 times 1 is 9. So we could factor this as x minus 9 times x plus 1 equals to 0. So that gives us two values. One of the value here is x equals to 9, and the other value is x equals to minus 1, right? So we have two values for x. So that means we can actually have two different series, right? So let's write down first series for x equals to, let's say, 9, right? So if I use 9 here, what do I get? My terms will be 2 times 9 minus 5, which is 18 minus 5 is 13, correct? And the next term will be 5 times 9 plus 3, which is 45 plus 3 is 48. And then we have 9 square plus 2. 81 plus 2 is 83, right? So that becomes first three terms. You may have to check whether do you have the constant d or not, right? So let's also calculate this value. Well, so what do we get? Difference, right? So d is equal to 48 minus 13, so 5, and 4 minus 1, 35, correct? So here also, if I check, it is d equals to 35, so that works, correct? That's what. Okay. Now, for x equals to minus 1, let's substitute minus 1 and get the three terms. You can also find d, substitute that in the first term. You could do that. But I'll prefer to straight away write down minus 1 here, right, and then check. So it is minus 2 minus 5 is minus 7, 5 minus 1 plus 3, which will be minus 5 plus 3 is minus 2. And then we have minus 1 square plus 2. So 1 plus 2 is 3. Now let's find d here. Is it constant or not? So that is a good check, you know. So you're adding 5 to move on. That is correct. So that is also correct. So these are the three terms which we have got. So we can now write down our answer that the terms are 13, 48, 35, or we could also have minus 7, minus 2, and 3, correct? So with this, we have complete solution to our test paper. I hope you understand and appreciate it. So these were the 13 questions which we took. The very first question was an excellent question, and then some in between were very tricky. Once you go through them, I hope you'll be well prepared for your test. Share your comments. That would be good for us. Also, share my videos with your friends. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.